Law of chemical equilibrium and equilibrium constant. Let us consider a general reversible reaction. A plus B in equilibrium C plus D, where A and B are the reactants, C and D are the products in the balanced chemical equation. Norwegian chemists Cato Maximilian Guldberg and Peter Wage proposed in 1864 the concentrations in an equilibrium mixture are related by the following equilibrium equation. Kc is equal to concentration of C into concentration D upon concentration of A into concentration B, where Kc is the equilibrium constant and the expression on the right side is called the equilibrium constant expression. The equilibrium equation is also known as the law of mass action. Law of mass action states that the rate of a chemical reaction is directly proportional to the product of the molar concentrations of the reactants at any constant temperature at any given time. The molar concentration, that is, number of moles per liter, also known as active mass. Reaction between gaseous H2 and I2 was carried out in a sealed vessel at 731 K. H2 gas plus I2 gas in equilibrium 2HI gas, reversible reaction. Many experiments with varying initial conditions were performed. Data obtained from all the experiments was analyzed and it was found that the expression square of the concentration of HI gas at equilibrium upon concentration of H2 gas at equilibrium into concentration I2 gas at equilibrium gives constant value as shown in table. Therefore, for the reaction H2 gas plus I2 gas in equilibrium 2HI gas, reversible reaction. The equilibrium constant Kc is written as Kc is equal to square of the concentrations of HI gas at equilibrium upon concentration of H2 gas at equilibrium into concentration I2 gas at equilibrium. Omitting subscript equilibrium, we have Kc is equal to square of the concentration of HI gas upon concentration of H2 gas into concentration of I2 gas. At a given temperature, the product of concentrations of the reaction products raised to the respective stoichiometric coefficient in the balanced chemical equation divided by the product of concentrations of the reactants raised to their individual stoichiometric coefficients has a constant value. This is known as the equilibrium law or law of chemical equilibrium. The equilibrium constant for a general reaction AA plus BB in equilibrium CC plus DD is expressed as Kc is equal to concentration of C raised to the power C into concentration D raised to the power D upon concentration of A raised to the power A into concentration B raised to the power B, where concentration of A, concentration of B, concentration of C and concentration of D are the equilibrium concentrations of the reactants and products. Equilibrium constant for the reverse reaction is the inverse of the equilibrium constant for the reaction in the forward direction. Equilibrium constant for reaction H2 gas plus I2 gas in equilibrium 2HI gas. Reversible reaction Kc is equal to square of the concentration of HI gas upon concentration of H2 gas into concentration I2 gas. Equilibrium constant for reverse reaction 2HI gas in equilibrium H2 gas plus I2 gas at the same temperature is Kc prime is equal to concentration of HI gas into concentration of I2 gas upon square of the concentration of HI gas. We find Kc prime is equal to 1 by Kc. Equilibrium constant for the reverse reaction is the inverse of the equilibrium constant for the reaction in the forward direction. If for chemical equation AA plus BB in equilibrium CC plus DD, equilibrium constant is Kc, then for chemical reaction NAA plus NBB in equilibrium NCC plus NDD, equilibrium constant is Kc raised to the power n.